Alright, so here's a couple word problems from 8.3, number 27. Take a look at this one. Alright, so we've graphed at this point, we've graphed in standard form, and now we're going to look at some word problems here and see what we come up with. Alright, so we have the function is given to us. Alright, so h of t, or just h, equals negative 16t squared plus 128t. Alright, and then it says, when does the firework explode? Alright, so the firework explodes here at this point there, and that is at the maximum, or we could also think about that as also at the vertex. Alright, so let's think about how we get our vertex here. Alright, so the vertex, we could get the x value by doing x equals negative b over 2a. So I'm going to identify my a, my b, and my c in standard form here. Alright, so there's a plus 0 here, and I'm going to put that for simple fact that my c value is 0. My a value is negative 16, and my b value is 128. Let's take these numbers and plug these in. So we have x equals negative 128 divided by 2 times a. 2 times a is negative 2 times 16, so we got x equals negative 128 divided by negative 32, and negative negative becomes positive. 32 goes into 128 4 times, so my x value of my vertex is 4. Alright, so if I follow that down, this is giving me 4 here. What I'm interested in is when does the firework explode? Okay, so when is the time? T is in seconds, so it explodes at 4 seconds. Alright, that's the x value of the vertex. And then part B says, at what height does the firework explode? And that's really, so there's the x. So now what I'm looking for is the y value of the vertex. Alright, so we have 4, so we can find the y value by taking 4, plugging into my equation, so negative 16 times 4 squared plus 128 times 4, and then there's no plus 0 there. Right? And if you plug this into your calculator, h of 4 is equal to 256, and then we'll put this in. This is in height. The function represents height in feet, so 256 feet. Right, so after 4 seconds, the firework explodes, and it is at a height of 256 feet. So here's one example of these problems. All right, so there's a couple more word problems in here I would love for you guys to try. I'm going to do one more for you guys. This is number 39. 39 and 40 are very similar. It says in exercise 39 and 40, find the value of x that maximizes the area. All right, so if you think about maximizing, anytime you have a parabola going down, the maximum is the vertex is going to represent the max here. All right, so I'm looking to maximize the area here. Okay, well, how do I find the area of this thing here? All right, so find the value of x to maximize the area, and part B is find the maximum area. So I have 2 dimensions here that we don't know, so x and x. All right, so we have, you could do this a couple different ways. So you have 1.5x is the entire thing from here to there. 6 inches is the entire thing from here to here. If you want to visualize this as the entire piece here, so that entire piece would be, so the total area here would be 6 times 1.5 times x, and then take away this area here, which is a square, which is minus x squared. So the area here is equal to 6 times 1.5, which is equal to 9x minus x squared. And I'm just going to rewrite this as negative x squared plus 9x. And I'm going to put a plus c there, which is plus 0, which is my c value. And since I want to maximize this, I'm going to find my vertex. My vertex is found through our formula that we've been using here, negative b divided by 2a. Identify my a here. My a is negative 1, my b is 9, my c is 0, and let's substitute it. So negative b, so negative 9 divided by 2 times -1 equals, these two becomes positive, 9 divided by 2, and you get 4.5. So I will be able to maximize this area when I let x equal to 4.5 inches. So if that length here of this piece and this piece here is 4.5 inches, I will maximize the area. That's part A. Part B says, well, what is the area? What is the maximum area? Well, okay, well then I'm just going to plug in my 4.5 in there and see what it comes out to be. So what is A equals 6 times 1.5 times 4 minus 4.5 squared, actually. So let me just rewind that a little bit. I'm plugging in 4.5, not 4. So 4.5 and minus 4.5 squared. So plug that into your calculator and you get A is equal to 20.25 inches squared. Alright, so 2 quick examples of these problems, but they all pretty much work out the same way. If you're looking to maximize, you're looking for the vertex, either the x value or the y value. And all these problems are kind of the same in what they're asking for. And sometime soon in the near future, we'll be looking for the x-intercepts of these problems, and you'll see how those are asked very shortly. All right, have a great night. Thank you.